Okay, folks, so we're going to look at the proof of the derivative of the cosine. So let's just let the cat out of the bag. We're going to say the derivative of the cosine function, we're going to show that it's minus the sine function. For really good visualization of how these trig derivatives really work, I highly recommend taking a look at the three blue, one brown videos that I've been posting online. Anyway, we're just going through the messy proof of this. And to do so, we're going to need to know how to work with the cosine of the sum of two angles. So we've got this identity here that we're going to need in the middle of this proof very soon, actually. So let's get into it. So we take, we're looking for the derivative of the cosine of x. We're stuck. We don't know what to do. So we jump to the limit definition. Says that we're just going to look at the difference quotient as h goes to 0. So right away you can see why we needed this sum of two angles identity. So here in this case x will be playing the role of alpha and h will be playing the role of beta. And so we get the limit as h approaches 0 of the cosine of x, cosine of h, minus the sine of x, sine of h. And let's just clarify that what I've just written is just that expression right there, minus the cosine of x, that's still this term right here, minus that goes all over h. So similar to what we did in the proof of the derivative of the sine function, I'm going to group together two of these terms. And so what we're going to see is it's going to fall out just like it did before, but in the opposite fashion. So I'm going to group together these two cosine terms and put them all over h. That's the cosine of x, cosine of h, minus cosine of x, all over h. And that's plus then negative sine of x, sine of h, all over h. So I should have done in the last step. Let's take a step to distribute the limit over the sum. So this gives us cos x, cos h, minus cos x, all over h, plus the limit as h approaches 0 of minus sine x, sine h, all over h. So as we saw in the proof of the derivative of the sine, notice that I've got two factors of cosine x here, and that our limiting variable is h. That x, even though it's a variable, it's constant as far as h is concerned. So I'm going to factor out these two. This gives me the cosine of x times the limit as h approaches 0 of the cosine of h minus 1 all over h. So I did two steps at once. First I factored a cosine of x out of both terms in the numerator, and then I went ahead and pulled that cosine of x outside of the limit. Why was I able to pull that cosine of x term outside the limit? Because the cosine of x, that factor, is independent of h. It's a constant as far as h is concerned. So then over here I'm going to do a similar thing. I'm going to go ahead and pull out the sine of x factor from there. So this gives me minus sine of x times the limit as h approaches 0 of the sine of h all over h. And now everything can be finished up just by remembering these two limits, which you've done the proofs of. So we get the cosine of x times this limit, we said evaluated to 0, minus the sine of x, and we said that this limit, hopefully you know this one by now, evaluates to 1, and so we're just left with minus the sine of x. And there we have the proof of the derivative of the cosine x, that the derivative of the cosine x is minus sine of x.